All right, let's talk Kubernetes. If you've ever felt like you're staring at this massive, super complex map of its world, just wondering, where do I even start? Well, you're in exactly the right place. We're going to take a journey through this map together. We'll start with the high-level tools you'll probably use every day, and then we'll start peeling back the layers to get to the core principles that make the whole thing tick. So at its heart, Kubernetes makes this one huge promise, right? It says, hey, give me the heavy lifting, I'll handle deploying, scaling, and managing your applications for you. It's basically become the go-to open source system for automating all those complicated, moving parts you find in modern software that runs in containers. But of course, that amazing promise comes with a catch. The ecosystem around it, it's massive. I mean, there are tools for literally everything, and it can be so overwhelming just trying to figure out which ones you actually need and how they all click together. Well, that's the exact puzzle we're going to start solving right now. Okay, so to get started, let's look at how most of us actually get our hands on a Kubernetes cluster in the first place. Now, you could build one from scratch, but let's be real, most developers turn to managed services that handle the most complicated part, the control plane. And that's exactly where services like Amazon's Elastic Kubernetes Service, or EKS, step in. You can think of EKS as your personal, expert Kubernetes operator. It runs the standard upstream version of Kubernetes, no weird flavors, but it takes on all the responsibility for keeping the control plane, which is really the brain of your whole cluster, healthy, always on, and ready to scale. And what does that mean for you? It means you, the developer, can get back to focusing on what you actually want to do, build amazing applications. Okay, so you've got your shiny new EKS cluster. It's up and running. Great, now what? How do you actually get your application on it? This is like the first major hurdle every single developer hits, and it brings us right to our next must-have tool, Helm. Because without a tool like Helm, you're just left wrestling with this sea of raw YAML files. It's a nightmare. You've got one file for your dev environment, then another one that's just slightly different for staging, and a third one for production. It's a total recipe for what we call configuration drift. Not to mention just plain old manual errors and a whole lot of headaches. And this slide just lays out the solution perfectly. On the left, you've got the chaos of raw YAML. On the right, the beautiful simplicity of Helm. You see, Helm basically transforms deploying your app from this risky, manual copy and paste game into a repeatable, automated engineering practice. This is huge because it dramatically cuts down on one of the most common reasons things break in production: simple inconsistency between environments. So how does it work? Well, a Helm chart packages everything up into one neat bundle. You get templates for all your Kubernetes resources, and then you have a single values.yaml file to plug in your environment-specific settings. And something that's really crucial to know is that modern Helm, specifically Helm 3, is way more secure. They got rid of an old component called Tiller, so now Helm talks directly to the Kubernetes API server. This makes security and permissions so much simpler. All right, next up, our apps are deployed, they're managed with Helm, but now they need to talk to each other. And in today's world of microservices, this service-to-service communication is where a whole new layer of complexity just pops up. And guess what? This is the perfect job for something called a service mesh. So what is a service mesh exactly? Think of it as a dedicated infrastructure layer that handles all the tricky parts of how your services communicate. So instead of you, the developer, having to code things like connection retries, encryption, or observability metrics into every single one of your apps, the service mesh just gives it to you, right at the platform level. It's a game changer. And the way it works is actually pretty genius. The mesh deploys this tiny, lightweight proxy, we call it a sidecar, right alongside every single one of your application containers. This little sidecar intercepts all the network traffic coming in and out. Because it sits right there, it can do some incredibly powerful things. We're talking automatic service discovery, really smart load balancing, enforcing top-notch security with something called MTLS, and even generating all the metrics and traces you need for amazing observability. Okay, so we've just looked at some really powerful, high-level tools that solve very specific problems. But to really get a handle on Kubernetes, it helps to take a step back and look at the bigger picture, the common systemic hurdles that pretty much every team runs into when they try to adopt this stuff at scale. And here they are. When you look at surveys and listen to community feedback, the same 5 hurdles pop up again and again. Security, networking, interoperability, storage, and of course, scaling. Now, tools like Helm and service meshes definitely help with pieces of this puzzle, But to truly master these challenges, we have to go a level deeper. We need to understand the fundamentals of how the cluster actually works. And that deeper level, it all starts with the brain of the entire operation, the control plane. If you want to overcome those big challenges in security and scaling, you first have to understand how your cluster thinks and how it makes decisions. So let's pop the hood and take a closer look at its architecture. Now, like we mentioned before, with a service like EKS, this whole control plane is fully managed for you. Amazon runs it in its own super secure network, and they spread it across multiple physical locations, what they call availability zones. The whole point of this architecture is to eliminate any single point of failure. It's all about making sure your cluster's brain is always online and ready to manage your work. But here's the crucial part. Even though it's managed, you still need to keep an eye on its health. You need to be asking questions. Is the latency for API requests starting to creep up? Are requests failing? Is etcd, which is the database that acts as the single source of truth for your entire cluster, is it responding slowly? Think of these metrics as the vital signs of your cluster's brain. You have to watch them. All right, so we've looked at the brain. Now let's talk about the resources that brain manages. We're talking about the CPU and memory that your applications actually use. Getting this part right is absolutely fundamental. I mean, if you want to run a stable, cost-effective, and scalable cluster, you have to nail this. And it really all boils down to two key values: requests and limits. A request is the minimum amount of CPU or memory you guarantee to a container. Kubernetes uses this number to figure out where to schedule your pod, which node has enough room. Then there's the limit. That's the absolute maximum the container is ever allowed to use. That's the hard ceiling, used for enforcement. Now, the way you actually specify these resources can be a little weird. For CPU, you'll see things like 500M, which just means 500 millicores, or half a CPU core. Easy enough. For memory, you'll typically use units like MI for megabytes. But you have to watch out for this last one. It's a classic gotcha. If you accidentally write 400M for memory, you're not asking for 400 megabytes. You're asking for 0.4 terabytes. Yeah, it's a super common mistake that leads to some very confusing problems. Okay, and this is really, really important to understand. Kubernetes enforces CPU and memory limits in completely different ways. CPU limits are proactive. If your container tries to use too much CPU, the kernel just slows it down or throttles it. No big deal. But memory limits? They're reactive. If a container goes over its memory limit and the node is running low on memory, the kernel won't slow it down. It'll just terminate it abruptly. We call this an OM kill, for out-of-memory kill, and it's one of the most common reasons apps just seem to crash out of nowhere. And it's not just CPU and memory either. The same exact principle applies to temporary disk space, what we call ephemeral storage. This quote here is straight from the official docs, and it's a pretty stark warning. If your pod starts writing too many logs or temporary files and blows past its storage limit, the kubelet, well, it won't hesitate to just kick the entire pod right off the node. It's called eviction. And you know what? That brings our whole journey full circle. We started way up at a high level, right? With tools like Helm and service meshes that do a great job of hiding the complexity. But as we've seen, to truly solve those big, hairy challenges of security, scaling, and stability, you have to understand the fundamental principles hiding underneath. You have to know how the control plane works and how resources are really managed. Look, the Kubernetes ecosystem can definitely feel like a maze sometimes. It's vast, but it's not unnavigable. Every single tool, every concept, it's just another part of the map that's helping you get where you want to go. So the real question I have for you is this. Now that you have a better view of the landscape, what are you going to build with it? Thanks so much for joining me on this journey.